Are we ready?
Yes, we feel free to begin when ready, and we have just started to record.
Okay. Hi, everyone. Dr. Dave Richardson. I'm your instructor for today's webinar entitled Data Analysis and Query Building with MedDRA. Assisting me today is Sarah Clark, one of the training coordinators for the MSSO. Just some housekeeping things to begin with. The webinar is scheduled for 2 hours. I have taught this webinar a number of times. It usually does not run a full 2 hours. But what will happen is at the end of the presentation of slides, we will go to questions and answers, and I will stay on the line long enough to answer all the questions that I'm able to answer. If there's anything that I need to refer to the help desk, we'll do that as well. But that would be basically what I want to say about the time constraints with today's webinar going forward. Now, you also have been told that you have access to a tool called Poll EV. This is one of those applications where you're able to submit answers and they will be displayed for the entire group to see. This particular webinar is not very interactive, so there will only be a couple of occasions where we'll use Poll EV, but we just thought it would be a nice feature to encourage some degree of interactivity. And the other thing that you have available to you is a chat box where you can type in questions. Occasionally during the webinar, I will stop and ask Sarah if we've accumulated any questions, and if not, I will then attempt to answer all the questions at the end of the presentation of slides today. Again, I'm only going to be speaking about data analysis and query building, so if you had other topics related to coding, etc., they're not the focus of today's webinar, and I don't want to take away from those who came into the webinar with a desire to hear about a very specific topic. If there is another webinar or training opportunity that I think can help you with a particular question that you ask, I will try to direct you in that manner. So without any further ado, let's get going with today's webinar. So again, my name is David Richardson. I'm a physician by training, specifically an adult neurologist. I'm a medical officer with the MedDRA Maintenance and Support Services Organization, and I'm physically based in Annapolis, Maryland, on the East Coast of the United States. So let's begin by introducing today's webinar. This slide is to remind me to tell you that MedDRA is owned by ICH, and because it is a living and breathing terminology that requires ongoing maintenance, the ICH created something called the MedDRA Maintenance and Support Services Organization, or MSSO. I am a consultant to the MSSO, and the job of the MSSO is to maintain, update, and train people on the use of the MedDRA terminology. So the activities of the MSSO are overseen by an ICH MedDRA steering committee, and the remainder of the slide provides the current membership of that MedDRA steering committee. This wordy slide is designed for me to remind you of a few things. The first bullet basically says that the material that I'm presenting is copyrighted and that copyright is owned by ICH. With the exception of the MedDRA and ICH logos, you can feel free to use this material in public presentations as long as you acknowledge that ICH owns the copyright. However, if you change the content of the presentation in any way, shape, or form, you should not imply or infer that ICH either supports or endorses the changes that you've made. The second bullet is legal language, so I will read it verbatim. The presentation is provided as is without warranty of any kind. In no event shall the ICH or the authors of the original presentation be liable for any claim, damages, or other liability arising from the use of the presentation. And the third bullet refers to third-party slides, and we don't have any in this particular webinar, so I will skip over that. So what are we going to do today? Well, first of all, we are going to assume that you have some background or knowledge of how terms are coded using MedDRA. In other words, if you get a report, whether it's from a patient, from a pharmacist, from a study site, from the internet, over the phone, and you decide that you want to enter that information in some form in your database, you will use MedDRA as a coding tool. We are going to assume for today's webinar that you have already properly coded verbatims or information into your database. And now what you're interested in doing is looking at ways to explore how to retrieve and present that data. So we will be discussing topics from one of the points to consider documents. The points to consider documents are ICH endorsed guidances that help you with certain aspects in using MedDRA more effectively and efficiently. And there is a points to consider document which is entitled the MedDRA Data Retrieval and Presentation Points to Consider document. So we're going to talk about applications of MedDRA in data retrieval, presentation, and analysis. We're going to demonstrate the use of MedDRA in building queries. And queries are tools that we create in order to be able to go in our database to look for cases of particular interest. Now, we're going to be talking about query building in general today, but many of you who work with MedDRA know that there's also a set of specialized queries called the SMQs, or standardized MedDRA queries. That is not the focus of today's webinar. That is a separate webinar. So if you want to learn more about that specific subset of queries, there's a webinar that is offered by the MSSO. And then following the points that I have already just mentioned, we'll conclude with our question and answer period. So there are two ways for you to get onto the Poll EV application. The first is to go to either your computer or your phone and be able to log on using a URL. The URL is pollev.com. When you get there, you want to enter MedDRA, MEDDRA 174 is the user name. You want to then click join. You'll skip over the next page and it will then allow you to respond to the slides asking for your input as we get to those. So that is one way of doing this. And the second way is if you have your phone handy and you want to scan that QR code into your phone, it's also going to take you to the Poll EV application. But again, remember, you will not be asked to provide information until we get to that particular slide. And in this particular webinar, there are not going to be a lot of these Poll EV interactions, but we wanted to have some in there. Okay. So let's get going. First of all, let's talk about this data retrieval and presentation points to consider document. This is what the document looks like. This is a document, again, ICH endorsed, that is developed and maintained by a PTC working group of ICH. It provides guidance on data retrieval and presentation options. This particular document is used not only by those who work in the biopharmaceutical industry, but also by the regulators around the world who regulate that industry. So, in fact, this data retrieval, PTC as I'll refer to it, is best used when it's used in conjunction with the MedDRA term selection PTC. For those of you who have taken any of our coding courses, you know that the term selection PTC is the guidance that is provided on how you go about deciding how to select an LLT from MedDRA that is the most appropriate for the verbatim information that you are attempting to database. It's also recommended that if your organization does not have its own coding conventions, that you can use the PTC document for those purposes. However, it doesn't make a lot of sense to say that you are going to follow the PTC if you are not adhering to the principles that are mentioned in the document. So, as I said, this PTC is developed by a working group of the ICH Management Committee. It is updated annually in the month of March each year. On March 1st, there is a new version that is released. Complete versions are available in several languages, including specifically English, Japanese, Chinese, Korean, Spanish, and Russian. There are also condensed versions of the PTC in the languages listed here at the bottom. These documents are available not only on the MedDRA website, but on the JMO, which is the Japanese Maintenance Organization, which is our partner organization that's responsible for maintaining the Japanese language version of MedDRA. So before we even start talking about data analysis, data retrieval, etc., we then need to also touch upon once more the key to doing quality data analysis. And that key is straightforward, but cannot be reiterated enough. It's accurate coding. And this comic is just designed to show you that when you are in the business of coding, MedDRA has over 90,000 LLTs available for you to use. And because of that degree of granularity and specificity, very rarely will you not be able to find something in MedDRA for your coding purposes. But that being said, you don't want to find the very first LLT that looks reasonably right and use it, because many times you will be missing out on specificity because you didn't look far enough into MedDRA. So you don't want to be one of those people who's on this line who looks for something simple, quick, and sometimes wrong and fall off the cliff. You have to acknowledge when you are coding, sometimes you're going to have to roll up your sleeves a little bit, maybe open up a medical reference if you're not familiar with the concept that you're trying to code. And sometimes you will have to do a little bit of research and homework before you finally come with the best possible LLT for your purposes. But it is absolutely worth it, because if you put incorrect, inaccurate, or very non-specific information into your database, when it comes time to pull it out for analysis, you will not have put yourself in the best possible position. So what are the specific topics that are covered in this PTC? Well, 4 basic topics here. General principles, we're going to talk about a few of these. Some general discussion of queries and retrieval of data, standardized MedDRA queries, and then customized searches as well. We are not going to say anything about the last 2, because in fact, those are the topics that are covered in the webinar on standardized MedDRA queries. We are going to talk about data retrieval, presentation, analysis, and query building in today's webinar. So we're going to really concentrate on the first 2 points here. So the first principle is the quality of source data. And again, I can't reiterate this enough. If you put junk into your database, it will not undergo some miraculous transformation and become quality data. So the coding piece is your only opportunity to get things right sometimes. And I would strongly recommend, when it comes to term selection, being aware of and following the principles that are described in the term selection points to consider document. The other thing that comes up is conversion of data that you may have gotten from another source. And that would be situations where perhaps you have acquired another product from another company, or you've purchased another company and its products. And the question for you will be, how do you take that data and integrate it into your database? And those are important decisions, because that's the only opportunity, again, when you will have the opportunity to make sure that your conversion of this data into your data set is quality and follows the rules that you've established in your data collection principles. So I'm of the opinion that anything that's important needs to be in writing. And so if your company has data retrieval and presentation practices, I think it is absolutely necessary that they be in writing. They need to be in writing because certainly, should you be audited by some outside organization, one of the first things auditors will want to see is, what are your documents to guide your behavior? They want to see your policies and procedures, your guidelines that you use, your internal conventions, etc. And so your data retrieval and presentation practices should be codified and should be available for physical inspection. It is also my opinion that they should be consistent with the points to consider documents and should mention certain key topics like coding conventions. Do you have any coding conventions that you follow within your organization, particularly for very specific things like clinical endpoints or adverse events of special interest, for instance? What are your data retrieval and output strategies, including, do you use SMQs? What procedures do you have in place from a quality assurance point of view to make sure that you actually do what you say you're going to do in your SOPs? When you use MedDRA over a long period of time and you're doing various searches, it's important to list the various versions of MedDRA that were used for these search activities, as well as describing in some detail your search strategy methodologies. What do you do about version updates? And that's not only for MedDRA, but for other tools that you might be using like WhoDrug, which are occasionally updated as well. And if in fact you are developing customized queries, it might be a good idea for you to specify how you actually do that within your organization. Now, another important principle that we just hammer in because it is crucial is that MedDRA is a standardized terminology with a predetermined hierarchy. MedDRA is, in a sense, hardwired. When we turn over a new version of MedDRA to you, all of the terms in it are hardwired, and their structure and their place in the hierarchy are predetermined. The LLTs are meant to be under certain PTs, which are meant to be under certain HLTs, HLGTs, and SOCs. And you do not get to change MedDRA as it's presented to you. If you do, you can no longer refer to it as MedDRA because it's not the standardized terminology. And if one were to make changes to the standardized terminology, you would have to be concerned then that a regulatory agency that is using the standardized version of MedDRA would have expected you to use the terminology in that form. And then therefore, anytime there are surprises because you've done something different with MedDRA, you may put yourself in a very uncomfortable situation of having to explain why you did not use the standardized version of MedDRA. On the other hand, we do have a process, the change request process, through a tool on the MedDRA website called WebCR, where you have the ability to electronically submit to us requests for changes to MedDRA. This could either be a request that you do not believe a term is in the right position in MedDRA, under the right SOC, for instance, or under the right PT, or you might want to suggest to us that you believe that there is a term that is missing from MedDRA that you need to do your day-to-day work and business. So there is an opportunity for you to have an impact on the composition of MedDRA. And one of the comments that people will always suggest to me or say to me when we are doing training courses is, why do you update MedDRA twice a year? Well, we do that so that MedDRA is on top of the current advances in medicine and science. But more importantly, if we were to make 1,200 changes in MedDRA, add 1,200 new terms to a new version of MedDRA, the experience has been that the vast majority, maybe over 98% of those change requests that were implemented come from you, the users. You tell us that you need these because these are coming up in your post-marketing reports, coming up in your clinical trials, and you need these terms in MedDRA to be able to do your job adequately. So if you think there is a deficiency in MedDRA, you need to be prepared to submit appropriate change requests. Now, the next set of points is regarding organization-specific data characteristics. These are things that I cannot help you with. And what I mean by that is your organization has to make some fundamental decisions at the very beginning about your database, how you're structuring it, what you put into it. Once you make those decisions, your ability to do certain things going forward may either be enhanced or actually limited because of the decisions that you have made. So for instance, databases are relational. They need to have fields, and the relationships between the fields need to be established and well thought out. How you structure your database is a decision that you're going to make. What you choose to store in your database is a decision that you're going to make. What you do about data conversion, meaning taking outside data like a legacy product or a product that you've gotten from another source and you need to put that data into your database. What about changes in your coding practices over time? Suppose you've gone from CoStart or WhoArc or some other dictionary to begin to start using MedDRA. you're going to need to understand that your database needs to be constructed in such a way that it will accommodate that type of activity. Also, you can't analyze things that you have not put into MedDRA. So for instance, you know that when we talk about PTs in our coding courses, we talk about the idea of multi-axiality and that some PTs are in more than one sock within MedDRA. And that then creates a situation where MedDRA assigns primary and secondary socks. If you don't record those secondary sock allocations in your database, you will not be able to use that as a method of any kind of analysis. Also remember that when you do something like split coding, where you choose to use more than one LLT to code an event of interest because you want greater specificity in your database, that creates an issue that you need to keep track of, because you want to be sure that you are not double, triple, quadruple counting because you have attributed more than one LLT to an event that you have databased. So, in my experience, when most people do analysis of MedDRA-coded data, they are looking at socks and PTs underneath that sock, and presumably those PTs are only shown once, and that is under their primary sock. But there are also two levels above that PT level that some people may choose to use for data analysis purposes, and those are HLGTs and HLTs. There is no rule that says that you can't use these higher level grouping terms for data analysis purposes. But my caution to you would be, there tend to be a lot more terms in the HLTs and HLGT levels than simply looking at PTs alone for a particular, within a particular sock. And therefore, if you do your data analysis at higher levels, there's the potential you're going to end up looking at a lot of cases that you weren't particularly interested in. So it's a good idea to look through the MedDRA terminology and see exactly what the HLTs and HLGTs are before you get involved with making a decision to do analysis at one of these higher level grouping levels within MedDRA. Let me just expand on that a little bit more. Suppose I was interested in going in my database and finding cases around the medical concept of blood pressure increased. And I looked and I said, hey, there's an HLT called vascular tests not elsewhere classified, including blood pressure. I'll do my analysis at the HLT level because it includes blood pressure. You can certainly do that, but here's the problem. You were interested in blood pressure increased, but because you chose to analyze at that HLT level, you're going to get cases that contain the concept of blood pressure decreased, cases related to certain vascular tests that you had no interest in, and you're going to end up looking at a lot of data that you hadn't intended to look at. The best analogy here is that your spouse sends you down to the ocean and tells you to catch 2 tuna fish for dinner, and you go down there with a net that's a mile wide. You're going to end up catching a bunch of things that you don't want to catch. So that's why you need to be very careful with these kinds of decisions about HLTs. Now, that's an error where you go with a net that's too wide, but you can also sometimes be too narrow when using these higher level grouping terms. So suppose I am interested in going into my database to find cases of Stevens-Johnson syndrome. The best way for me to describe Stevens-Johnson is, it's a situation where you take a drug or product and your body just does not like that product. And the way that it manifests that is that your skin begins to peel, like you have third-degree burns. It causes ulcerations on all your mucous membranes, like your nose and your mouth. And those people are desperately sick. So let's say you wanted to find cases of Stevens-Johnson syndrome, but you didn't know much about it, and you looked in a medical reference, and it said Stevens-Johnson syndrome is a bullous condition, and you say, oh, it's a bullous condition. And you look in MedDRA, and you find an HLT that says bullous conditions, and you say, I'm going to run all the terms underneath HLT bullous conditions. That's going to help me find cases of Stevens-Johnson syndrome. There's a flaw in your logic, because not every case that you get is going to say the patient had Stevens-Johnson syndrome. That's the name of the two people who were credited with discovering or at least describing this disorder initially in the medical literature. But sometimes the reports will not say Stevens-Johnson syndrome. They will say the patient had exfoliative dermatitis. Same condition, different name for it. So that particular concept is under a different HLT. And the problem here is if you limited it just to bullous conditions, you will have missed all these other cases of interest because you did not choose to take a larger net for your fishing expedition. So we see two sides of the coin. This one where you were fishing with too large a net, got more than you wanted, and this one where you were too narrow, trying to use just this one HLT when there may have been other HLTs that would be relevant. So just be aware of that when you are doing higher level grouping term analysis. So we talked about multi-axiality, and again, that is the principle that medical concepts, preferred terms, sometimes have to be in more than one SOC within MedDRA. The impact on the frequency of medical conditions of interest should be considered because multi-axiality does have an impact on that. So if I'm trying to do a thorough investigation of my data to see if I have cases of renal problems, and I say, well, I'm interested in renal problems, so the only SOC that I need to be worried about are cases that were coded to renal and urinary disorders, I've made a mistake. Because if I do that, I'm not looking in other SOCs where there are medical concepts that are very germane, very relevant to the presence of renal disease. For instance, if I don't look in investigations, I'm not going to see those cases where the only reported event was some laboratory that's reflective of renal function, like blood urea nitrogen or creatinine. I would not have looked in the SOC for surgical and medical procedures where there is a PT for renal transplant. Clearly, anyone who's had a renal transplant had a diseased kidney. And therefore, the point here is that I needed to look in that SOC as well. And in social circumstances, there's a PT for artificial kidney device user. And the other thing that you should recognize about these three SOCs is they are unique. They are the so-called non-multi-axial, single axial, uniaxial SOCs, in that if you see a PT in one of those three SOCs, you are seeing it in the only place that it's going to appear in MedDRA. So always be considering multi-axiality when it comes to data analysis to make sure that you are turning over all of the important and relevant rocks. So as I said, when people do their analysis, in my experience, most times they are looking at data based upon primary SOC assignments. However, secondary SOCs also provide us an alternative view of data, and it also gives us an alternative way of presenting data. So let's go back to this thing about higher level grouping terms for a minute. Suppose I have a database, and this database that I am dealing with is very limited. It's only these two slides, but it is data comparing my drug, literally, that's the name of my product, my drug, to placebo in some trial that I've done. And what I'm looking at here is the SOC for investigations, which is one of these single axial SOCs. So these PTs that you're seeing here on these two slides are only going to appear in that particular SOC in MedDRA. But when I'm looking in the typical way of SOCs with PTs underneath them, and the assumption is that these PTs are only displayed one time under their primary sock. What if I asked you, relative to placebo, do you think my drug has some kind of safety issue going on relative to placebo? And what is that safety issue? Now, these are not huge numbers. This is only 2 slides. In reality, when you get this data in your database, it may be hundreds and hundreds of pages like this. When I begin to look at it, I might try to convince myself that there's something going on here just by looking at some of these small numbers. But the kinds of concepts that are represented here, aminotransferases or glucose or amylases or lipase, or this one, which is occult blood, blood pressure increase, these kinds of things. I'm not 100% sure that I have something here. And I literally take this so far as to say, if I had to bet my house on it, would I be willing to bet my house on making any conclusion on these data the way they are displayed? And the answer is, for me, I'm not willing to do that. On the other hand, suppose I took that same identical data and decided to look at it at the HLT level. Now, when I look at it at the HLT level, I begin to see that relative to placebo, there's a suggestion that something's going on with my drug, perhaps as it relates to liver function test. Now, that may have been known already, but it may not have been known. I'm not telling you that with 100% certainty there is a liver function issue with your product. I'm simply telling you that by having raised your analysis one level to the HLTs, you begin to glean something here that you would not have if you had restricted yourself just to PTs. And in my time as a pharmacovigilance physician in several companies, many times the first inkling of a signal came because of something you saw at your desk and you got a gut feeling. And sometimes when you get a gut feeling like you have here, now you have enough to be able to convene a meeting of the appropriate folks in statistics and data management, et cetera, to say, I think something's going on. Let's do a more formal review of this process. So when it comes to data analysis, think about the level at which you're looking, because it sometimes gives you a different view. And sometimes these early, fast, and dirty ad hoc analyses are designed to do nothing more than decide whether you should bring additional colleagues in so you can be more formal in your attempt to analyze, is there a potential signal or event of interest? So MedDRA versioning is important when it comes to data analysis. As you know, MedDRA is updated twice a year. In March, it's a complex release because potentially all 5 levels of MedDRA could be affected. But the September 1st release is a so-called simple release, in that only PTs and LLTs changes at those 2 levels are reported in single or simple releases in September. Okay. When it comes to documentation, as I said, if you're using a particular version of MedDRA for data retrieval and presentation, you should document the version that was used, because obviously MedDRA versions change every 6 months with a new release in terms of having new terms added or potentially having changed terms that were changed or moved to different areas. So every time there's a release, we give you multiple ways of trying to figure out what's new or what's different. For instance, we have in our what's new document generally somewhere between 6 to 10 pages of telling you the major things that have happened. Changes to HLTs, changes to HLGTs, changes to SMQs, new things that may have happened. We also supplement that document by having a What's New webinar that is held twice a year as well. We have also a best practices document on the MedDRA website that provides some guidance on how one goes about, as an organization, developing a reasonable versioning strategy. There's also a tool called MVAT, the MedDRA Version Analysis Tool, which allows you to compare any 2 versions of MedDRA. So you could compare the current version, 28.1, to 28 to see what happened over that 6 months time. And it will not only give you a list of all the changes, a summary table, for instance, it will tell you there were 1,900 new PTs added to MedDRA, or that 23 PTs were demoted to LLTs, or that 67 PTs were moved under a new primary SOC, or that 27 MedDRA terms went from being current to non-current or non-current to current. This is what the MVAT tool allows you to do. And as well, in the release, we actually apply the MVAT tool to the version being released to the prior one and give you a version report so you can see the summary of what's different from the preceding version in the version report that we provide for you. But also to emphasize just once again, we're talking about data analysis today. So one of the things we'll be talking about later on is creating queries to go in and do some investigating and digging in your database. And if you are going to create a query with MedDRA, you should be sure that the version of MedDRA used to create the query matches the version of MedDRA that was used to code the data that you are querying. Otherwise, you can get into situations of mismatches and misinformation. Let's talk a little bit more about, in a practical sense, what versioning can mean in terms of errors you might make in data analysis. Here's a situation where in version 22.1 of MedDRA, we had two PTs, fractured ischium, pelvic fracture. And let's just say for arguments in a fictitious database, we had 15 events at the PT level for fractured ischium and 5 at the PT level for pelvic fracture. What happened was we got a CR from a user that said, I think you guys have made a mistake. Fractured ischium is not a separate concept. It's a type of pelvic fracture. And we thought about that and we said, that user is absolutely correct. So in the next release of MedDRA, 23.0, we took that PT, fractured ischium, and we demoted it and made it an LLT under pelvic fracture. Now, if you were not paying attention and didn't know that that change had occurred, and you were simply looking at a printout of pelvic fracture at the PT level, and you were looking at data in this time frame, you would say, oh, we had 5 events at that level. And now I look at a printout again of pelvic fracture with the next release in this time frame, and suddenly I say, oh my God, we had a 4-fold increase in pelvic fractures. No, you didn't. You have the same number of events, you just have had the impact of a version change in that this number went through from 5 to 20 because you now have subsumed 15 events that should not have been at the LLT level, excuse me, at the PT level to begin with, and they are now captured as LLTs under pelvic fracture. Here's another example. We had in the SOC, psychiatric disorders, a PT for vascular cognitive impairment. We had 20 events at that level. And a user again comes and says, you placed that in the wrong SOC. Vascular cognitive impairment is not a psychiatric disorder. It's a nervous system disorder. And we thought about it and we said they're absolutely correct. And so in the next version of MedDRA, we moved that PT from psychiatric disorders to nervous system disorders. Now, if you were a lazy data analyst and said, oh, well, my company makes an antidepressant, that's the only product that we make, so I only need to look in the psychiatric disorders SOC data because that's where all of our data is going to be, you'd have a problem because you would not have looked in the SOC where those cases that you previously were aware of have now been moved to. You suddenly would have thought a miracle had occurred and that concept had completely disappeared from your database. So these things are impactful and there are reasons why you should pay attention. So again, I'm just going to briefly just say to you again, the MVAT tool is an excellent tool. We have a wonderful webinar that takes you through in detail how to use the MVAT tool. The MVAT tool has 3 main things that it allows you to do. As I said, it allows you to compare 2 versions of MedDRA. to get, first of all, a summary page and then detailed information on all the changes that have occurred between two versions. And you can select the two versions. It doesn't have to be the preceding version. I could compare 28.1 to 24 if I wanted to for some reason. The second thing it allows me to do is take any term in MedDRA, type that term in, and search and see the entire history of that term in MedDRA. What levels it was at. Was it active or inactive? Did it get moved to a different SOC? Did it get promoted? Did it get demoted, et cetera, et cetera? And the third one, which is particularly important, is data impact report, where you take a properly formatted data set, load it up into this MVAT tool, and it will not only tell you the changes that have occurred between those two versions, but it will also then tell you how the data you've uploaded would be impacted by the changes that have occurred. And if you need then to do any kind of recoding of any kind, then that's the opportunity to do so. So again, I would point you to the MVAT analysis tool as an excellent tool if you haven't been aware of it, haven't been using it, or have been doing these kinds of analyses with pen and paper. It's automated. It's been there for years for you to be able to use. Okay, a few more things on MVAT. It comes in all the versions of MedDRA language that we support. So you can change it from English to an interface in French, for instance, if you're more facile with that language. And the output can also be changed to a language which you are more facile with. It has the ability to run supplemental change reports, meaning supplemental changes are changes that have been approved by my colleagues who review change requests but have not yet been implemented in MedDRA. So in fact, even though 28.1 is the current version, my colleagues are already working on what goes into 29.0, and that is something you can see in the supplemental view of the web-based browser to see what terms are going to be in the upcoming version of MedDRA. And you can do this very same thing using the MVAT tool in that particular platform. You also have the ability to see not only primary SOCs, but secondary SOC assignments. And as I said, there's a two-part webinar available on the tools page of training materials that allows you to see the MVAT tool in greater detail. So let's move on now and talk about the use of MedDRA in data retrieval, presentation, and analysis. And I'll ask Sarah, at this point, do we have any questions that have come up?
We do not at this time.
Okay, then let me keep moving forward. All right. So, again, most of you begin your analysis or do your entire analysis based on primary SOC. I often ask people if they've ever heard of the internationally agreed order of SOCs, and they all say, no, I've never heard of it. And then I will ask them if they've ever looked at a SPC or summary of product characteristics document. And they say, oh yeah, I've looked at those. And they haven't looked at them very carefully, because otherwise they would have noticed that that document uses this internationally agreed order of SOCs. What does that mean? It means that if I were listing the 27 SOCs in alphabetical English, it would start with blood and lymphatics and it would end with vascular disorders. But in other languages, because of differences in their alphabet, the order may be completely different. So you can see the folly in trying to use alphabet as a way of listing SOCs. And instead, what this classification attempts to do is not look at alphabet, but look at clinical severity. So in fact, at the top of this internationally agreed order of SOCs are bad things like infections and infestations, and neoplasms, because these are things that hurt patients, and if not known to be a potential risk of your drug, can hurt your drug as well. And at the bottom of the list is going to be things like social circumstances. But the point is that this internationally agreed order of SOCs is one of the files that you receive when you get a MedDRA release every 6 months. Also consider when you're doing analysis that you could also look at HLTs and HLTTs, as we did before. But then there are other ways of displaying this, including line listings, tables, and graphs. What's the benefit of doing primary SOC analysis? a broad overview, and for the reasons that we said, because the MSSO assigns a primary SOC for multi-axial PTs. PTs are only going to be displayed one time, and there's no chance of double or triple or quadruple counting. The limitations of analysis by primary SOC is incomplete groupings and sometimes very lengthy output. So in coming to understand a drug, depending upon how your brain is wired or miswired, if you're more of a right brain person, you may prefer to see data displayed this way. So if I were given a new drug that I was told that I'm now responsible for monitoring, I might want to look at this if I'm a right brain person. And if I look at it, the one thing that I would hopefully conclude here is I don't know much about this drug, but when I start digging through the weeds to get to learn something about it, I should really be concentrating on psychiatric and nervous system issues, because there seem to be a large number of those relative to the other SOCs. Now, these don't necessarily mean that these are serious psychiatric or nervous system events, but at least tells me that cumulatively there are a lot more of them. And so this kind of display of looking at bar graphs, for instance, may help me get a feel for what the data is trying to tell me. But this is what I was raised on when I went into industry in the late 80s. Everything was line listings. And this is how a lot of regulatory agencies want or demand to see the data presented. It's familiar, it's comfortable. You know, sometimes when you get into very elaborate graphical things with overlapping Venn diagrams and vectors and things, it's all very, catchy, but not very easy to understand. And sometimes simplicity is best. So sometimes you become absolutely focused and you know exactly what your concern is, and your search strategy can be appropriately focused because you have a clear vision of what you're trying to do. And those are situations where you might include in the analysis things like secondary SOC assignments. This requires programming if you don't already have it built into your platform, or it's already not a module in a commercial product that you may have purchased. Benefits of secondary SOC analysis is that it gives you a more comprehensive view of medically related events. The limitations is that it will also be showing you primary and secondary SOCs on the same screen. And you need to remember that's what you've asked to see, so you don't get into the problem of double and triple counting. Other strategies would be using HLGTs or HLTs. May make more sense when you clearly are focused on what you are interested in. SMQs, and then again, customized searches. And again, we're not going to talk about those last two at all today. Okay, so we're going to do an exercise now. You get a request from your new boss. Your boss, who doesn't know much about what you do and doesn't know much about how you do it, comes in and says to you, I just got off the phone with a regulatory agency, and they want to know how many cases of autoimmune disease we have. And you say, you mean autoimmune? And he says, yeah, that's what I said. And then your boss goes on to tell you, oh, and I told them we would get back to them with an answer in a half hour. You've got an issue now, because you're supposed to do something, but not only are you supposed to do it, but the person who is now directing you to do it has given you a time limit without checking with you first to see how easy or hard it would be to meet that time limit. So let's do this. Let's first of all start out by looking at the data in my database. Luckily, it's only 3 slides, but let's look at them. I have reports, cases that are coded under several different SOCs, including blood and lymphatics, cardiac, endocrine, eye, hepatobiliary, immune, musculoskeletal, and skin. Now, the question here is, how many of these cases are autoimmune? So when I start out, I say, well, first of all, my first problem is that some of these things, I don't even know what they are. I don't know what Evans syndrome is. But I do also see other things like autoimmune neutropenia. Well, I know enough to know that when I see that adjective autoimmune, it probably means that they're autoimmune in nature. But how about anemia? Is it autoimmune? Well, you will say to me, it could be, and you're absolutely correct. But here's what I want you to appreciate. Looking down here under cardiology, cardiac disorders, we have a PT for myocarditis, but we also have one for autoimmune myocarditis. And your hope is that your coder's coded correctly. And so when I see two cases of myocarditis, that tells me that they came across two reports where it said the patient had myocarditis, and that's how they coded it. But there were 4 other cases where the report said the patient had autoimmune myocarditis or myocarditis that was autoimmune in nature. And that is why they chose to code under this medical concept. The same thing would be true for anemia. There is an anemia PT, but there's also one for autoimmune anemia. So one of the things that you have to rely on in doing your analysis is first and foremost that the coding has been accurate. But if I move on now to the second slide, it becomes still difficult. There are a few pieces of low-hanging fruit like polyglandular autoimmune syndrome type 1 and autoimmune uveitis, but I don't know what chorioretinopathy is, much less birdshot chorioretinopathy. And how about these disorders? Are any of those autoimmune? I don't know. And again, the clock is ticking. My boss has given me all of 30 minutes for him to be able to respond to a regulatory agency. And then how about this one? Same thing. I don't know what polymyalgia rheumatica is. Is alopecia autoimmune? Is vitiligo autoimmune? I do see 4 reports where it said autoimmune disorder. And my presumption there was my coders chose that because that was the only information. It said the patient had a history of autoimmune disorder or autoimmune disease without specifying what organ or organs may have been involved. So let's play true to the exercise. Let's just look at one slide. This is the first slide. These are the reports under blood and lymphatics and the ones under cardiac disorders. And my question to you is, looking at these, I want you to decide how many cases of autoimmune disease are on this slide. So for instance, you say, well, autoimmune neutropenia, I know I have at least 5, but I want you to look through the rest of them. And then what I want you to do is get a number in your mind. And once you have that number in mind, then what you're going to be doing is going on to PollEV and just typing in a number so that I know how many of these you think are autoimmune. So I'll give you a few minutes to just start looking at these, thinking about them, come up with a number, and then type in the number of cases that you believe are autoimmune in nature. Someone says 9, someone says 12, 6, 11. Second person must have said 9, 10. Another 9. We'll just wait for one more. But here's the point. The point is that everyone involved on today's webinar, you couldn't come up with a common number because some of you may have recognized some of these to be autoimmune. Some of you may not have recognized any of them and just guessed. And what you can't do after a half hour is go back and tell your boss your guests and expect that they will comfortably submit that information or communicate that information to a regulatory agency. So let's move on. So let's try to figure out how we can answer that question. So the first thing I'm going to do is take my database and I'm going to display it here in this spreadsheet here with these columns. And I'm going to first of all segregate these things out based upon their primary SOC. So the first 1, 2, 3, 4, 5 here have blood and lymphatics as their primary SOC, and cardiac and endocrine and eye and hepatobiliary. This one, which was autoimmune disorder, is not surprising that its primary SOC is immune system disorders. But even when I segregate these things out, it doesn't really help me. It doesn't help me because even though I'm looking at blood and lymphatics at the 5 different concepts that have blood and lymphatics as their primary SOC, this one I believe to be autoimmune, but again, I still don't know what Evans syndrome is. So not being able to define some of these things is really the issue. But here's what I want to take advantage of. You know that the rule for primary SOC allocation is what's the prime site of manifestation. So if the prime site of manifestation was the heart, then cardiac would have been its primary site. If it was endocrine, then it would have gone to the endocrine site. But also, when we assign terms to MedDRA, if we think that there are reasonable secondary links, we have those secondary links as well as secondary SOCs. So we need to rely on the folks who populate MedDRA having done their homework and making sure that those concepts, which were autoimmune in nature, also had a secondary SOC link to immune systems. So let's restate the problem. My system only shows primary SOCs. How do I view secondary SOCs for a set of terms? You need help. You need to open up the MedDRA toolbox. And when you open up the MedDRA toolbox, specifically here, the browser, which you know comes as a desktop browser and a web-based browser and also a mobile browser. But for purposes of where we're going to really concentrate on today, desktop and web-based browser, that the browser has built into it a tool that's going to be able to help you. So this is just more on the browser. Obviously, you need to have an ID and password to be able to get in. You can view MedDRA, you can view SMQs, you can change languages, you can change the interface, and you even have the ability to export results into the research bin and store them on a hard drive, for instance. Okay. The other thing, though, here in terms of specific features are that for the desktop and web-based browser, among the tools that are available, they have available to you the option to say, let me see secondary link or secondary SOC information. So let's look at the tool that's going to help us figure this out. So the first thing I'm going to do is show you this, which is I took all of my data and I put it into a spreadsheet that looks like this. Those were the 3 slides of data. And now I'm going to go into the browser. This is the browser in English, version 28.1. I open it up. And there is a tool at the top called the Hierarchy Analysis tool. And that tool is going to help me. When I click on that, it opens up the tool. It says you're in the Hierarchy Analysis tool. You're in English 28.1. It has several things that are selected, including I want to see HLTs in the output, HLGTs, and I also want to see secondary SOCs, because that's going to be key for this analysis. The other thing that it says is, do you have data? So when I click on data or import data, it says, in order for me to even look at your data, you need to properly format it. I need to see it in an Excel spreadsheet. That Excel spreadsheet needs to have 3 columns. These are the columns. This is what should be in each column. And you can have up to 100,000 rows. I already knew that. That is why I created that spreadsheet that I already showed you, because I knew that that's what the tool was going to ask me for. So now it's asking me to browse and find that spreadsheet. I find it, I plug it into the tool, and I run the tool. And here's what the tool gives me. It tells me I have just done a hierarchy analysis. I asked to see secondary SOCs. This is the date. This is the time. Now, it also tells me that I asked to see secondary SOCs, HLGTs, and HLTs, because remember, those were the 3 boxes that I left checked. Now, what I want you to appreciate is here are my PTs. And you will notice that some of them are repeated once or displayed once, but some of them are repeated more than one time, like autoimmune neutropenia is here more than once. The polyglandular one is more than once. Myocardial infarction is here more than once. So let's start working across the spreadsheet and see what it tells us. It tells me that I have a term called anemia with that code, with that PT. PT. That's the HLT it's under. That's the HLGT that it's under. How about if I take autoimmune neutropenia? Same thing, code, PT. It's under two different HLTs and two different HLGTs. Why? Because that PT is multi-axial. And one of the SOCs that it is under is blood and lymphatics. And the other one that it is under is immune system disorders. And then this column says, what's the primary SOC? Well, blood and lymphatics is the primary SOC for that disorder. And by definition, immune system disorders is a secondary SOC. And so that's the case for all of these here. The ones that have multiple displays, it's telling me that that PT is multi-axial and in more than one place. But what I want to pay attention to is this one was autoimmune neutropenia, which I was pretty comfortable was going to be autoimmune in nature. And when I begin to look here, I see that there is an HLGT called autoimmune disorders. And if the people who placed these terms in MedDRA did it correctly, every concept, PT concept, that is autoimmune will have its primary link to its primary SOC, but it should also have a secondary link to this secondary SOC. So the thing that I'm going to do now is go in this HLGT column. I'm going to take all of these terms here, and then I'm going to do a little bit of, let me see if I can get this to show me what I want, which is, let's see. I'm going to ask it to sort, and I'm going to ask it to sort alphabetically. And then it's going to ask me, do you just want me to sort that column or the columns around it? And I say, sort everything. Look at what it's done. It's now sorted those alphabetically. And look at this cluster under HLGT. Autoimmune disorders, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 of those PTs have a link to this HLGT. Let's now look and see what they are. Here are those displayed right here in yellow. And here's what I would like you to appreciate. You will see that of these 11 PTs, only one of them has immune system disorders as its primary SOC. And that shouldn't be surprising that it was the one, autoimmune disorders. All the others have some other primary SOC, but they had a secondary link to that HLGT autoimmune disorders. And this helps me tremendously because now I start looking through the list and now I find out Evans syndrome is autoimmune. Bird-Sharp chorioretinopathy is autoimmune. Primary biliary cholangitis is autoimmune. Polymyalgia rheumatica, rheumatoid arthritis, vitiligo. I didn't even need to know anything about those medical concepts to be able to use this tool to get that answer. So now with that information, what I'm able to do now is take those 11, go back to the original slides and begin to count up the cases. And I find that I have a total of 30 cases from my 3 slides of data that are autoimmune in nature, either because they have a primary link to immune system disorders or a secondary link to that HLGT autoimmune disorders. And I did this in a very short period of time by using this tool. That is very, very powerful. It didn't even require me to know what some of these things were to be able to do that. So what I also want to show you is this ability to display secondary SOC information can be found in several places when one is using the browser. If I were doing a simple search in the browser and I typed in headache, it would allow me to export that information and to ask to see the secondary SOC. So for instance, I have analgesic rebound headache displayed twice. It's displayed twice because once it's showing it to me in its primary SOC, which is nervous system, and a second time in general disorders and administration site conditions. So that's one display of secondary SOC information. A second way, if I were going to use the research bin to export terms out of the browser into my research bin, it also allows me to select the secondary SOC designation. And the third way was what we just did, which was to use the hierarchy analysis tool and be able to select that, properly format data up to 100,000 rows and import it into the tool. So that was a demonstration of a mannerism or a mechanism for doing secondary SOC analysis. Now, people ask me all the time, well, why would we want to do that? Well, all I can tell you is this. I have had students in my classes and have had experience to know there are regulatory agencies that do analyses of your data on the basis of secondary SOC allocation because it gives different views. Sometimes it gives information that would not have been intuitive if you just stayed in the primary SOC view. And the difficulty that you would have is, were you to be in a situation where your data was analyzed in that mechanism and you were asked a question about it, if you can't even replicate the analysis, how are you going to be able to answer the question? It'll be extremely difficult. Okay, questions at this point now, Sarah?
No, still no questions.
Okay, let's move forward then and talking about actually developing a query using MedDRA. Again, let's assume that you have properly coded thousands and thousands of data into your database, and now you want to get out stuff to see if you have cases of concern. So the first thing about queries is, let's define what a query is. So you start out with a database, and the database has data. And because you've used MedDRA, the kind of data that's going to be in there are LLTs. So you will have, for instance, a number of cases, case 1, 2, 3, whatever number of cases, and you would have recorded a bunch of LLTs that were characteristic or part of that case. Now, once I have my database full of LLTs, suppose I am interested in trying to find out whether any of these people have multiple sclerosis. Well, the first thing I need to do is do a lot of reading on multiple sclerosis so that I understand it. What is it? What does it mean? What other names are used? And then I would find out that other terms I should be considering are demyelinated disease, for instance, and then some very specific disorders that are related to demyelination, like Miller-Fisher variant is a demyelinated type of Guillain-Barré syndrome. So the point here is that now I read that. Then I start reading about the signs and symptoms that people with MS might have, for instance. And so I'm looking up things like double vision, ataxia, facial weakness, any of the falling, all these things that may be indicative of the physical signs and symptoms. Then I might start looking at investigations like MRI abnormal or increased spinal fluid protein or other things that go along with making a diagnosis. Then I might look at treatments for people that have multiple sclerosis. And I might look at lifestyle changes because of having the diagnosis, like bedridden, wheelchair user, uses a cane. Those are all concepts that I would want to put on my list that will be my query. So I select those PTs, medical concepts of interest. I put them on my query. And by definition, I then also include the LLTs that are subordinate. I now have my query. Now this is when the hand waving works, because I take my query and I have to load it into a query tool. And you say, well, what's a query tool? Well, most of you will have a commercial platform that has the ability to do this for you. Others don't have that because you're in small companies or you're just working off your laptop. And we've created at least one query tool built into the browser, which is a query tool that will allow you to run properly formatted data against the existing group of standardized MedDRA queries. We won't talk about that today because that is a topic that is covered in the standardized MedDRA query webinar. But for our purposes today, I create this generic query. I load it into the tool. The tool is now comparing my LLTs on my query with LLTs that are in the database. And every time there's a hit, something here is here, then it says you need to pull that case and look at it because it could be a case of multiple sclerosis. It's not telling me that it is. And unfortunately, you're moaning and groaning. You mean I still have to look at the case? Absolutely. But what does a query do to make your life better? Well, instead of looking at all 10,000 cases in your database, by running that query, it may say, these are the 550 cases that we recommend you looking at, and you need to put an eye on them to see if they really pass muster of being a case of multiple sclerosis. So, queries make your life better. Yes, you still have to look at the queries. And you should be thankful that you have to look at the results. Because once you get to the point where humans no longer need to do that introspective analysis, a lot of us are going to be out of jobs. So be thankful that you still have work to do, manual, cerebral, intellectual work to do. So some general things when it comes to building queries at MedDRA. You cannot spend too much time defining the condition of interest. Sometimes to define something very simple, let's say I wanted to make a query for obesity. We spend some time in class 5-10 minutes because what I get from everyone is the usual, well, it's a BMI over, BMI is fine, except then eventually what we come to is a slide that I show of Arnold Schwarzenegger on the day that he won his 6th Mr. Olympia title. On that day, his BMI was probably 37, but we come to agreement that there is no one in the class who thinks that that man is obese. So that tells us that a definition of obesity that's limited only to BMI is not going to be sufficient. And then we end up with a secondary measure like hip circumference or waist circumference. So the point is, even little simple things like defining a fall, you'd be shocked when you get together and say, okay, let's write down a definition for what a fall is. And 10 hours later, you still haven't come up with one because it has to take into account all kinds of things, such as that it's unintentional, what the position of the body be after executing a fall. From a realistic point of view, what kind of mechanisms physiologically could your drug be responsible that could cause a fall? You need to do all those things. The other thing in building a query is you need to pay attention to not only the terms that you include, but also the terms that you don't want to include, the ones you specifically exclude. And you might want to say, my query was designed to find this, and it was not intended to find that. Why would you do that? Well, suppose your drug is given to 65-year-old men for some medical condition, 65 and older, given to men 65 and older, and you suspect that it may be associated with some kind of hearing loss, and you want to create a query to find cases of hearing loss. And you go into MedDRA and you start pulling out MedDRA terms for congenital forms of hearing loss. That is an absolutely silly thing for you to put in your query, because by definition, the risk doesn't begin until you get exposed to your drug, and they don't start taking the drug unless they're male and over 65 years of age. So you would have put a bunch of terms that could pull cases from your database that you end up having to look at that you were not interested in. So inclusion and exclusion criteria are key. When you are selecting terms, specifically the PTs with their subordinate LLTs that go in your query, you can use HLTs and HLGTs if appropriate, but understand that you may end up making that query such that it's not very helpful. It's got so many terms and it's so big and it's so onerous, it excludes very few cases in your database when you run it. Also make sure that you look in those non-multi-axial SOCs for the reasons that we mentioned when I talked about renal failure. You need to look at investigations. You need to look in surgical and medical procedures to find the cases of renal transplant. You need to look in social circumstances. And at any level that you are looking in MedDRA, if you have concerns about what you're looking at, make sure you look at the neighbors around it, the other LLTs, the other PTs, to make sure that you feel like you're barking up the right tree. One other thing, I said you use PTs and subordinate LLTs. It may be that occasionally you might want to add an LLT in isolation to your SOC. Why would you do that? Suppose you are interested in some kind of infectious process. At the PT level in MedDRA, you're going to see terms like bacterial or microbial. But if you are interested in specific organisms, those are going to be found at the LLT level. So if you were interested in actually finding strep and staph, which was described at the LLT level, then you may need to run those LLTs in your query as well, because they are not going to lose the specificity that you desire if you look at that level. Once you develop your query, you store it for future use. Maybe you want to put it on a shared drive so that your colleagues can contribute to it, edit it, add things. And if you're going to use it longitudinally, then every time there's a new release of MedDRA, you need to update this thing to make sure that it's accurate. So let's just talk through this whole idea of developing a query. I just want you to concentrate on one thing and one thing only. Be sure to turn over all of the relevant rocks. If I ask you to build a query for cardiac disorders and you are a lazy person, you might go into MedDRA, do a top-down search and find the HLGT cardiac arrhythmias and say, gee, I don't need to do anything else. I'll just take all the HLTs, all the PTs, and all the LLTs that are underneath that HLGT, and that's my query, and I'm done. But have you created a good query? Absolutely not. And how can I say that with such certainty? Because you didn't look in the investigation SOC, where there's a PT for heart rate irregular. You didn't look in surgical and medical procedures, where there's a PT for implantable defibrillator insertion and cardioversion. Those have to be in a good query for cardiac arrhythmias. What about when having the arrhythmia causes some collateral damage? For instance, what happens if you break into a ventricular arrhythmia and it causes you to faint? You might want to have concepts under the HLT disturbances in consciousness. What if your arrhythmia causes, let's say you go into atrial fibrillation, break loose a blood clot in the right atrium, in the left atrium, and you end up having an embolic stroke. You might want to have neurologic signs and symptoms that go along with an ischemic stroke. There are other cardiac places that you didn't look, like cardiac disorders, cardiac signs and symptoms. What if it just makes you short of breath? You need to look under dyspneas. So again, you were lazy by just picking one HLGT. You didn't turn over all the relevant rocks, including this one. You didn't look in general disorders and administration site conditions, and you missed the most important concept that you would need to have, which is reports of cardiac death in your database, which until proven otherwise, you would have to prove that that was not arrhythmogenic in nature. So just to reiterate this point once more, here's an actual database of 10 patients. And these are the events reported at the PT level for each of these patients. And I gave this spreadsheet to my friend, Dr. Jones, and I asked her to tell me whether this was likely or unlikely to be a case of cardiac arrhythmia. And you will see that of 10 cases, she selected 3 that she said were unlikely. This one, the patient had nausea and vomiting. I don't disagree with that. How about this one? She said the patient had a cerebral vascular accident and prostate cancer. Well, I might want to go back and check that one just to make sure this wasn't an ischemic embolic stroke from somebody that went into atrial fibrillation. The other one she chose was breast cancer and menopause. I'm all right with that one. But the other 7, she says, that's a potential case. You need to look at it. I want you to just look here in this column, which is the primary SOCs of these concepts. And I want you to pay attention to how many times the event that scared Dr. Jones did not, I repeat, did not have cardiac disorders as its primary SOC. Sudden death, is under general disorders. Abnormal ECG is under investigations. Dyspnea is under respiratory. Syncope is under nervous system. Pacemaker generated arrhythmias, general disorders. Cardioversion, surgical procedures. Long QT syndrome congenital is in the congenital SOC. How about this one? Cardiac assistance device user is under social circumstances. Look at all the times when just confining yourself to the cardiac disorders SOC would have caused you to create an inadequate query. So that's a lesson to be learned. Turn over all the rocks. If you're not particularly good at query making, you might want to do this by committee. But understand that you cannot turn over data to a regulatory agency that presumably does this better than you and then comes to understand your drug better than you do. That's a problem. So, just one last quick demonstration for purposes of this webinar, just trying to be respectful of people's time. I just want to show you how a query actually works in terms of what it generates at the end. This is not intended to be anything other than we built an artificial tool that basically created a query and query results. So here's what we're going to do here. I was asked to create my query for cases of cardiac failure. And these are the terms that I came up with. And I have everything from fatigue to dyspnea to cor pulmonale to pulmonary edema to heart transplant. I mean, I went into a lot of different SOCs to try to find terms that I thought would be appropriate for this query. And what happens is, just like I said, you take your query, and I'm going to copy all these terms. And that's when the hand waving started, as you recall, because now I'm going to open up this query tool, which I created. And I'm going to paste these in, and I'm going to ask it to run the query for me. Now, the first thing you'll notice is it turned a bunch of these things green. But other than turning them green, it doesn't seem like it did anything. Well, the reason it seems like it didn't do anything is I haven't been honest with you. If you look at the spreadsheet, you see it goes from A to E. It goes to A to E because I've been hiding stuff from you. And when I unhide what I've been hiding from you, in the background is my query tool. And it took the data from that database and showed me the patients. And here are the patients listed here, 20 patients. And it looked at their reported events and matched them up against my query. And every time a term on my query matched something as a reported event for that patient, it turned green. And then you will see here that that's why patient number 1, who had nausea, vomiting, and diarrhea, has no green marks, whereas patient number 2 had actually cardiac failure in his report. This patient had a bunch of things going on as well, congestive hepatopathy or peripheral edema here. How about this one here? You say, gee, this guy had paroxysmal nocturnal dyspnea, but it's not green. It's not green because I didn't put it in my query. I missed that case because despite my effort to put together what I thought was a good query, I missed a concept that would have been reasonable. So by doing this, you then see that you're able to identify, by using the query I presented, 12 of 20 cases that are potential cardiac failure cases. But the more time that I spend on the query and being careful with what I put in the query, the greater the chance of picking up those cases like case number 3, which I had initially missed. But that is how a query works. Okay. Okay. So what have we learned? We've learned that developing queries is a valuable skill to have. It helps you to get a better understanding of what you put in your database, what the implications are for your product in terms of things that you might want to start doing differently, perhaps in your trials, adding some more surveillance, maybe more EKGs, maybe a chest x-ray, maybe certain laboratories. With a marketed product, it may lead to things that you might want to change in terms of instructions for administration. It may change a number of things because you begin to glean more about what's going on with your product as it relates to safety-related things. So MedDRA is a powerful tool for developing queries for data retrieval, but you have to have solid medical knowledge of the disorder of interest. You also have to have solid knowledge of MedDRA itself. Because MedDRA has such great specificity and such great granularity, it allows you to be very creative in creating your queries. And it is well worth the effort when you spend the effort to create a query, to share it, maintain it, upkeep it, so that you do not have to keep reinventing the wheel when current concerns come up over and over and over again. So in summary, what we have done today is to discuss some topics from the PTC, or Points to Consider document related to data retrieval and presentation. We talked about applications of MedDRA in data retrieval, presentation, and analysis. We demonstrated a tool, the hierarchy analysis tool, which showed you how to take properly formatted data and be able to look at secondary SOCs, which help you to identify autoimmune concepts that might have been extremely difficult if all you had was the list of PTs under which that were placed under their primary SOC. It was a valuable analytic tool. These are some important contact pieces of information: the MedDRA website, email for the help desk. This is a link to frequently asked questions, and fortunately, we also have the answers there as well. The URLs for the various MedDRA browsers. This is the link for going into WebCR and submitting a change request. You're already familiar with the training page because you signed up for this particular webinar, and this is where you go to find support documentation. So I'm just going to open up the MedDRA browser and just take you very quickly on a tour of how to find some of these things. So here's the MedDRA browser, a wealth of information. But when you go here under how to use, you go under support documentation and you're going to see a few things. The first thing you're going to see is this tab here for points to consider and best practices. So here's where you would go to find the points to consider document that we talked about today, which is your guidance for how to do things related to data retrieval and presentation. You can see this is not a very long document. It's only 35 pages long, but there are all kinds of benefits to being familiar with this. Candidly, what we do right now is to create these webinars which cover a lot of, but not all of the information that's in this document. We didn't touch on any of this stuff today, which is related to SMQs. But if you are using SMQs, or if you intend to use SMQs, it would be important for you to know about that. The other one I want to show you here was best practices. And the best practices document is a document that's designed to give you some guidance. So what happens all the time is people ask me about versioning. What should we be doing about versioning? You come up with a new version every 2 months, or every 6 months. What should we do? We have a discussion about versioning not only for ICSRs in post-marketing environment for trials. The answer to the question, what should you do as it relates to versioning, I'm going to be absolutely evasive for a reason. I'm going to show you that we give you 6 different options that start with option 1 and go all the way up to option 6. Option 1 is very simple. It says you take a particular version of MedDRA, you're using it in some project or activity, and you just use that one version of MedDRA from beginning to end. Even if your activity takes 3 years, you do everything with MedDRA, including the analysis of whatever it was with that one version of MedDRA. And that is the equivalent of riding around on a skateboard. And most of you say, well, that's ridiculous. You're not allowed to do that. And you're probably right. So option 1 is not what you're doing as a biopharmaceutical developer, but it may be, let's say you're a pharmacy student. in a master's program writing some kind of paper on a formulary, and you decide to look at some topic, and by the time you start your project, it's MedDRA version 27 that you're using to analyze your data, and by the time you're finished, it's version 29.1. And assuming that your conclusion is sound and is always going to be backed up by evidence, no matter how much evidence you have, the likelihood that using the latest version is going to change your conclusion may be very slim, in which case you chose option one. And in the limitations section of your paper or thesis, you're going to say, one of the limitations is I only used a single version of MedDRA throughout the entire life of the project. So I'm just showing that to you to say, as you go through these, that was very bare bones reason with a purpose to use option one. On the other hand, when you get to option 6, it says that you should recode the trial data from all trials in a project on an ongoing basis with the most recent version of MedDRA. Now, when you say to me, which should I do? It really comes down to two things. You should do what you're capable of doing. I can't tell you to do something that you don't have the resources, the money, the personnel to do, but you should do what you're capable of doing. And the second part of that statement is you should be capable of doing what you're required to do. So if you are trying to create documents or data for a regulatory agency, and their expectation is that you are going to be using option 6 in terms of your versioning strategy, then you need to make your management aware that's the expectation and make sure you have adequate resources to be able to do that. Otherwise, you're going to be in a lot of trouble. Okay. The other thing I wanted to just show you is here are some other guides here. An introduction to MedDRA. This one is related to SMQs as well. Those are the main things I wanted to show you about the website as it relates to today's discussion. Again, we were looking at the browser, and just to refresh your memory again, this is where the hierarchy analysis tool was found that I used to do the secondary SOC analysis. So at this point, I'm going to stop, and I'm going to ask Sarah, do we have any questions from the audience?
We do not at this time.
When I have no questions, and Sarah knows I say this every time, it scares me, because it either tells me that I have been so crystal clear in my presentation, you understand everything, or it means I'm so unclear that you don't even know what questions to ask. I would like to assume it's the former rather than the latter. But in any event, my message to you is you are the best possible people to create queries for your product. You know it intimately. You know your product, you know the preclinical and clinical stuff that's available, you know what the IB looks like, you know what the proposed labeling looks like, you know your environment there, whether your company is risk adverse or not. You know all those things. You are the ones who should be driving the idea of queries. What you don't want to do is violate a rule, and the rule is very simple. You don't want a regulatory agency to understand your product better than you do. And there's no reason for it. You own all the data. You have access to the same analytical methodology. So that's what you should be doing. So if no other last minute questions have snuck in, I just would encourage you to continue to expand your MedDRA knowledge by webinars, face-to-face courses, video casts, the Learning Management Center, any of the number of ways that we try to make you better MedDRA users. And if nothing snuck up here in the end, has anything come in, Sarah?
Nothing yet, no.
All right, then I'm going to wish, first of all, I'm going to thank Sarah for her help today, and I'm going to wish each and every one of you a productive remainder to the rest of your day. This is Dr. Dave Richardson signing off from today's webinar.